Gasketed Form 7 fittings are generally not permitted in Class 1 or Class 2 locations. They are usually permitted only in Class 3 locations or other applications where explosion-proof sealing isn't needed. Oversized seal-offs might not be listed for use in hazardous locations. Inspect them to verify they are listed for the specific hazardous location class and are correctly installed. Reducers might not have visible markings indicating they are listed or explosion-proof. The only way to verify their listing is to check the manufacturer's product data or the approval certification from a recognized testing laboratory. Gasketed enclosures with contact blocks inside are not typically permitted in Class 1 or Class 2 locations. The contact blocks may create an ignition source inside the enclosure, which could cause an explosion. Based on the information, it appears the following conditions may not be compliant with the National Electrical Code, or NEC, for hazardous locations. Firstly, gasketed Form 7 fittings in Class 1 or Class 2 locations. Secondly, oversized seal-offs that may not be listed. And thirdly, gasketed enclosures with contact blocks in hazardous locations. To protect yourself, firstly, inform the contractor who engineered the job about your concerns. Secondly, request documentation demonstrating the specific listings and approvals for the fittings and enclosures in question. And thirdly, if the documentation is not provided, or if the equipment does not meet the required standards, you should decline to install it. Clearly communicate your concerns to the contractor and document all conversations and actions taken. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations are those where combustible dust is or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 3 locations are those where easily ignitable fibers or materials are handled, manufactured, or used, but are not likely to be suspended in the air in quantities sufficient to produce ignitable mixtures. Explosion-proof equipment is designed to contain an internal explosion without causing an external hazard. Seal-offs are used to prevent the passage of gases, vapors, or flames through conduit systems. Reducers are used to connect conduits of different sizes. Enclosures are used to protect electrical equipment from the environment. Contact blocks are used to make electrical connections. The NEC is a set of standards for the safe installation of electrical wiring and equipment. Listings and approvals are certifications from recognized testing laboratories that indicate that equipment meets specific safety standards. It is crucial to ensure that all equipment used in hazardous locations is properly listed, approved, and installed in accordance with the NEC. Failure to do so could result in a fire or explosion. Explosion-proof enclosures are designed to contain an explosion within the enclosure and prevent it from propagating to the surrounding environment. The enclosure must be strong enough to withstand the pressure of an internal explosion, and it must have flame paths that cool the escaping gases to below their ignition temperature. Dust ignition-proof enclosures are designed to prevent the ingress of dust and to prevent the escape of sparks or hot metal particles that could ignite a dust cloud. The enclosure must be tightly sealed to prevent dust from entering, and it must be made of a material that will not generate sparks. Intrinsically safe equipment is designed to be incapable of releasing enough energy to ignite a flammable atmosphere. The equipment must be designed with low voltage, low current circuits, and it must be protected against short circuits and overloads. Non-incentive equipment is designed to not cause ignition under normal operating conditions. The equipment must be designed with limited energy circuits, and it must be protected against abnormal conditions. Purged and pressurized enclosures are designed to maintain a clean, inert atmosphere inside the enclosure. The enclosure is purged with a clean gas, such as nitrogen or air, to remove any flammable gases or vapors. The enclosure is then pressurized to prevent the ingress of flammable atmospheres. When selecting equipment for hazardous locations, it is important to consider the following factors. Firstly, the class and division of the hazardous location. Secondly, the group of the hazardous material. Thirdly, the temperature rating of the equipment. And fourthly, the listing and approval of the equipment. The class and division of the hazardous location indicates the type of hazardous material that is present and the likelihood of it being present. The group of the hazardous material indicates the specific type of flammable gas, vapor, or dust that is present. The temperature rating of the equipment indicates the maximum surface temperature that the equipment will reach under normal operating conditions. The listing and approval of the equipment indicates that it has been tested and found to be safe for use in hazardous locations. It is important to consult the NEC and other applicable standards for specific requirements for equipment used in hazardous locations. Proper installation and maintenance of equipment is essential to ensure safety. Regular inspection should be conducted to identify any potential hazards. Any damaged or defective equipment should be repaired or replaced immediately. Personnel working in hazardous locations should be properly trained in the hazards of the location and the safe operating procedures for the equipment. When working in hazardous locations, it is important to follow all safety precautions. Use only approved equipment and tools. Wear appropriate personal protective equipment such as respirators and safety glasses. Be aware of the potential hazards and take steps to avoid them. If you are not sure about something, ask for help. The NEC provides detailed guidelines for the selection, installation, and maintenance of electrical equipment in hazardous locations. It is essential to consult the NEC to ensure that all equipment is installed and maintained in accordance with the code. The authority having jurisdiction, or OJ, is responsible for enforcing the NEC. The AHA may be a local, state, or federal agency. It is important to work with the AHA to ensure that all electrical installations are in compliance with the NEC. In addition to the NEC, there are other standards and regulations that may apply to electrical installations in hazardous locations. These standards and regulations may be issued by organizations such as the National Fire Protection Association, or NFPA, the Occupational Safety and Health Administration, or OSHA, and the Environmental Protection Agency, or EPA. It is important to be aware of all applicable standards and regulations and to ensure that all electrical installations are in compliance with them. The design and installation of electrical systems in hazardous locations require specialized knowledge and expertise. It is important to hire qualified professionals to perform this work. Qualified professionals should have experience in designing and installing electrical systems in hazardous locations and should be familiar with the NEC and other applicable standards and regulations. Proper documentation is essential for electrical installations in hazardous locations. Documentation should include drawings, specifications, and test reports. The documentation should be maintained in a safe place and should be readily available for inspection. Regular inspections are essential to ensure that electrical systems in hazardous locations are properly maintained. Inspections should be conducted by qualified personnel. Any deficiencies identified during inspection should be corrected immediately. Training is essential for personnel working in hazardous locations. Training should include information on the hazards of the location, the safe operating procedures for the equipment, and the proper use of personal protective equipment. Emergency procedures should be in place in case of a fire, explosion, or other emergency. Emergency procedures should be regularly reviewed and practiced. The use of appropriate equipment is crucial for safety in hazardous locations. Explosion-proof enclosures, dust ignition-proof enclosures, intrinsically safe equipment, non-incentive equipment, and purged and pressurized enclosures are all designed to prevent ignition in hazardous locations. Selecting the right type of equipment for the specific application is essential. In addition to selecting the right type of equipment, it is also important to ensure that the equipment is properly installed and maintained. Proper installation and maintenance will help to prevent failures and ensure that the equipment operates safely. Regular inspections can help to identify potential problems before they become serious. When working in hazardous locations, it is important to be aware of the potential hazards and to take steps to avoid them. Following all safety precautions can help to prevent accidents and injuries. Understanding the NEC requirements for hazardous locations is crucial for ensuring safety. The NEC provides detailed guidelines for the selection, installation, and maintenance of electrical equipment in hazardous locations. Consulting the NEC and other applicable standards is essential for designing and installing safe electrical systems in hazardous locations. Remember to always prioritize safety when working in or around hazardous locations. This includes using the correct tools for the job. It may be tempting to cut corners or use a tool that isn't quite right, but this can be a recipe for disaster in a hazardous environment. Make sure you have the right tools for the specific task you're performing and that they are in good working condition. And remember to inspect your tools before each use to ensure they are safe to use. For example, using non-sparking tools can prevent accidental ignition in environments where flammable materials are present. Moreover, proper grounding and bonding techniques are critical for minimizing the risk of electrical sparks. Grounding provides a path for stray electrical currents to flow safely to the ground, while bonding connects different metal parts to ensure they are at the same electrical potential, preventing voltage differences that could lead to sparks. It is also imperative to implement a comprehensive lockout-tagout, or LOTO, program to prevent accidental energization of equipment during maintenance or repair. LOTO procedures ensure that equipment is de-energized and locked out before any work begins, preventing unexpected startup that could lead to injuries or explosions. These procedures should be clearly documented and consistently followed. Moreover, regular audits and inspections are key to maintaining a safe working environment. Conduct periodic audits to assess compliance with safety regulations and identify potential hazards. Inspections can help detect deficiencies in equipment or procedures before they lead to accidents. Address any issues promptly and document corrective actions taken. This continuous improvement process is essential for maintaining a high level of safety. In addition to the technical aspects of electrical safety in hazardous locations, it's important to consider the human factors involved. Fatigue, stress, and complacency can all contribute to accidents. Ensure that workers are well rested, properly trained, and aware of the risks involved. Encourage a culture of safety where employees feel comfortable reporting potential hazards without fear of reprisal. This proactive approach can help prevent accidents before they occur. Furthermore, emergency preparedness is paramount. Develop and regularly practice emergency response plans that outline procedures for dealing with fires, explosions, and other incidents. Ensure that workers know how to evacuate safely and where to find emergency equipment such as fire extinguishers and first aid kits. Regularly review and update these plans to address changing conditions and lessons learned from past incidents. The NEC addresses specific requirements for intrinsically safe systems in Articles 504 and 505. It also covers requirements for purged and pressurized systems in Article 502. Proper selection and installation of wiring methods such as rigid metal conduit, or RMC, intermediate metal conduit, or AIMC, and cable types are specified in Articles 501 through 506. These articles also detail requirements for ceiling fittings, explosion-proof enclosures, and other protective measures. Furthermore, it's essential to understand the equipment marking requirements outlined in the NEC. Equipment intended for use in hazardous locations must be clearly marked with information such as the class, division, and group for which it is approved. This marking helps ensure that the equipment is suitable for the specific environment in which it is installed. It is also necessary to consider the temperature rating of equipment used in hazardous locations. The temperature rating indicates the maximum surface temperature that the equipment will reach under normal operating conditions. This temperature must be below the ignition temperature of the flammable substances present in the environment. The NEC provides guidance on selecting equipment with appropriate temperature ratings for different hazardous materials. Moreover, proper ventilation is crucial for reducing the concentration of flammable substances in the air. Adequate ventilation can help prevent the formation of explosive atmospheres. Ventilation systems should be designed and maintained to effectively remove flammable vapors, gases, or dust from the workplace. Remember that continuous education and training are essential for maintaining a high level of safety in hazardous locations. Stay up to date on the latest codes, standards, and best practices. Participate in industry conferences, seminars, and workshops to enhance your knowledge and skills. Share your expertise with others to promote a culture of safety throughout the organization. By taking a proactive and comprehensive approach to electrical safety in hazardous locations, you can minimize the risk of accidents and protect lives and property. Remember that safety is everyone's responsibility. Foster a culture of vigilance where employees are empowered to identify and address potential hazards. By working together, we can create a safer working environment for all.